The next stage of this lecture is to look at distance-time graphs. So a distance-time graph is one where distance is plotted on the y-axis, so that is the vertical axis, and time is plotted on the x-axis, that is the horizontal axis. Now we can use these graphs to actually represent a journey, and we're going to look at one now and how we can calculate different things from looking at different aspects of the graph. So here we can see an example of a distance-time graph, and we've already got a line plotted on it, so we can have a look at the different aspects of this and see what it can tell us, or see what it explains. We're going to split this graph into three sections. We're going to look at this straight slope section here, then we're going to look at the level section in the middle, and finally this slope section towards the end too. So we're going to name those A, B and C. Now if we look, and we're going to look quickly at section B first, we can see that the time passed is between 10 and 30 seconds. So there's 20 seconds passed in total. But the distance they have travelled from their start stays at 5 meters. So between 10 seconds passing and 30 seconds passing, their distance does not change at all. So this leads us to one of the first main points on a distance-time graph. A horizontal section means they are staying still. They are not moving at all. The object is stationary. That's the technical term for it. If we look at sections A and section C, we can see that they are a straight sloped line. This means as time is passing, their distance is increasing at regular intervals, hence a straight slope line. So whenever you see a line like this, a straight slope on a distance time graph, that means that they are travelling at a constant speed. Their distance is changing at a constant rate. Every second that passes, they travel the same extra little chunk of distance. There's another thing you can learn from a distance time graph about their speed. If you look at the steepness of the slope, you can tell if they're moving faster or slower. So section A and C have the same steepness, so they have the same speed. A steeper slope means their distance is increasing more for every second than a shallow slope. So a steeper slope means a higher speed, a more shallow slope means a lower speed. One of the calculations that you're going to be required to make in this GCSE from this type of graph is to work out the speed probably in a particular section. Now the way that we can do that is by calculating the gradient of our graph. We're going to look at section C, and you need to bear in mind that the gradient can be calculated by looking at the vertical difference between 2 points and divided by the horizontal difference between the same 2 points. So if we go back to our graph, our 2 points that we've got in question are between here and here, because that is our section C. So if we look at the vertical difference between those 2 points, we've got 15 meters minus 5 meters, so that gives us a vertical distance or difference of 10 meters. Now if we look horizontally, where it starts and where it ends, we've got a time difference of 50 minus 30 seconds, which equals 20 seconds. So we can use that to calculate the speed through section C. Our gradient is equal to our vertical difference between the 2 points, and that was 10 meters. Divided by the horizontal difference, that was 20 seconds. So we end up with a speed of 0.5 meters per second. And you can actually see that the units of speed make perfect sense because you've got meters divided by seconds. If you look at our gradient, you've got meters divided by seconds. And that is a nice easy way to calculate speed from a distance against time graph. And remember, that makes sense because if we've got a steeper slope, as we mentioned before, you'd have a bigger vertical difference divided by the same horizontal difference, so you get a bigger speed. If you had a shallower slope, you'd have a smaller vertical distance divided by the same horizontal distance, so you get a smaller speed. So in summary, we can say that for a distance time graph, a horizontal line means that the object is stationary, so it isn't moving. A straight sloped line means the object is moving at a constant speed. The speed of the object can be calculated from the gradient of the line, which is the difference in the vertical distance between the points and the horizontal distance between the points. And that the steeper the slope is, then the greater the speed the object is moving with.